Good evening, everyone. Welcome back to our next educational webinar in the Learn at Home series brought to you by the University of Rhode Island's College of the Environment and Life Sciences, and more specifically, Cooperative Extension, which Dr. Alissa Cox and I are here representing. Tonight's webinar is about septic systems, and more specifically, keeping your septic system at its best to protect public and environmental health and your wallet. So there's something here for everyone. I am joined by Dr. Alissa Cox, who is a clinical assistant professor in the College of the Environment and Life Sciences Department of Natural Resource Science. She's also the director of the New England Onsite Wastewater Training Program and Center, which is a very well-known program of cooperative extension that she will probably talk a little bit more about. Next slide. Thank you. So we always take this opportunity to fill folks in on what cooperative extension is and why we exist at a university. In fact, cooperative extension exists at the land-grant university in every state. So regardless of where you're tuning in from, our friend in California here, the University of California is the land-grant institution. UC has a cooperative extension unit, as does Massachusetts at UMass, etc. And it is our duty, our mission to bring the science-based resources of the university out to people and communities, in our case in Rhode Island, and we've been doing that since 1914, not Alissa and I specifically, obviously, but many others. And our roots are really in food systems and agriculture, but we have kind of pivoted with the times, and many of our programs fall within these strategic areas of focus on the right-hand side of the screen. I bring this up for you all because if you are a landowner, a forested landowner perhaps, if you have a backyard garden, if you have a septic system or a well, if you're interested in renewable energy or increasing energy efficiency at your home, if you know you have ticks anywhere in your vicinity or children in your family who might want to be involved in 4-H, we have something for you. We have programs that disseminate science-based information around all of these areas. And one of our a few of our guiding principles relate to inclusivity and access to the scientific information we have. And so my one ask of you all is that if you hear anything you love tonight that you think anyone in your life might benefit from, please share information about us with them. That's the best way that we increase our reach. We really believe in environmental justice, and the only way we're going to promote that is making sure we're reaching everyone. So thank you for all of that, and make sure you link up with us. I'll tell you how. So a couple housekeeping items, and then I'll turn it over to Dr. Cox. There is in the bottom right-hand corner of your screen 3 dots. If you click on those dots, it'll bring up a prompt for a Q&A box, which is different than the chat. You're welcome to use either, but it's easier for me to keep track of your questions in the Q&A. So enter them there. If you can't find it, enter them in the chat, no problem, and we'll do our best to answer them at the end of Alissa's presentation. Also, you will receive an email from something like messenger@webex.com after this webinar concludes, if you're here with us live or if you registered. And there's a brief survey there that we would love for you to fill out. It helps us improve these programs. We read all of the results that we receive, and really thank you in advance for taking the approximately 60 seconds it'll take to fill that out. Thank you. And finally, this session is being recorded. We have a URI Cooperative Extension YouTube channel that's available. You can access this recording within the week, as well as nearly 60 other recordings of Learn at Home webinars and other video content that we have developed over the past year or so. And all of the recordings are closed caption post-production for the hearing impaired. So please, again, share those webinar links with your friends and family. Without further ado, one of my newer friends and colleagues, Dr. Alissa Cox, that is Buddy in the background barking at the cat. I'm going to turn it over to you. I have to take care of this fun issue at my house. Enjoy, everyone.
Thank you, Kate. So welcome, everybody. So I am the director of the New England Onsite Wastewater Training Program and Center, which mostly provides technical training for professionals in the onsite wastewater treatment or septic system industry. But today I'm here to talk to you and give you sort of the homeowner perspective, the nuts and bolts, kind of best things to do to make sure that your septic system behaves itself and that you don't have sort of a hair-tearing nightmare on your hands. So kind of talking about what the things we'll talk about today. So I'm going to start with a basic overview of what septic systems are, how they work, what the different components are, some sort of trouble spots. I'll kind of give a really quick baby cameo of what an advanced treatment system does. We don't have time to get into the specifics of that, but I'll kind of touch on that briefly. Then we're going to kind of talk about what you can do as a person living on land to preserve your local ground and surface water, specifically with respect to septic systems. And then I'll kind of wrap up with some final thoughts, okay? So, human waste, not shocking to any of us after this pandemic, is a source of disease, right? So we know, right, if you end up getting things contaminated with fecal matter or poop into your mouth, chances are you may become ill, right? This is something they realized in the 1860s, various cholera epidemics, and at some point they realized, oh, if we mix raw human sewage and waste with drinking water, people get very ill. So we know now that we can use protective barriers to interrupt these fecal oral disease transmissions. And so we can keep the poop out of our systems, right, by having a sanitation barrier and clean drinking water. We can wash our hands. We can make sure that there are appropriate measures to keep our crops safe and clean so that we are not contaminating ourselves with disease-causing organisms. Septic systems are part of this component. They function as protective barriers. They keep our fecal matter out of our drinking water and they keep it off our ground surface where we might come in contact with it or where maybe our food things come in contact with it. So that's what we're going to kind of focus on today. Some of you may be wondering, septic systems, don't you mean cesspools? And no, I do not. So we'll kind of talk about these things. So this is what sort of a diagram of a cesspool looks like. So here you have your house, you have a drinking water well, and then all of the waste in that household gets piped out to a cesspool. And a cesspool is some sort of underground structure made of a variety of different things. They can have different configurations. Sometimes they're made of weird old steel drums that are sort of in various states of rusting and collapse. They can be sort of built in place, sort of brick oven underground kind of looking things. They can be all kinds of weird below ground sort of chambers. And the idea is that they allow the wastewater to come in and then they send it down. The problem with these is there's almost no wastewater treatment. So a cesspool is different from a septic system. So here we have a cesspool next to a septic system, and kind of we'll start talking through some differences. So you'll notice the cesspool is just this whatever below ground structure that somehow lets the wastewater escape through the bottom, usually sometimes through the sides. And in a septic system, you have distinct components that are watertight until you get out to the drain field. And there are major important differences that we'll get into. So a cesspool is an outdated technology. People put these in, pre and through the 1960s, and then they realized that these actually provide almost no wastewater treatment. And so because they're often small, it could be like a 50-gallon steel drum would be an example of what sometimes people use as a cesspool. They have a very small footprint, and so they take up a small amount of room, but that's a problem because then when you add wastewater to that, it works kind of like a hypodermic needle, injecting raw wastewater into the local groundwater without much time for it to get treated. On the flip side, septic systems are modern technologies that are designed specifically to treat wastewater. And they are sized for modern households and the way we use them today. And the idea is that in a properly functioning septic system, we're spreading wastewater over a large area of soil, and that soil provides some treatment, which I'll explain in a Another difference between these two systems is that cesspools, because they're some sort of underground structure and they're big enough to kind of hold wastewater, oftentimes the bottom of that cesspool is pretty close to the groundwater, which means that there's not a lot of time for that raw wastewater to turn into anything other than like your drinking water. Septic systems designed so that there's a lot of distance between the bottom of where the water starts trickling into the soil and the groundwater table. So that is an additional sort of time and space for treatment. Cesspools are major contamination concerns for nearby wells and nearby surface waters, and a properly functioning septic system should not really pose a contamination risk for the nearby things. And so we'll kind of get into some of these. So just really important distinction. Cesspools are not the same thing as septic systems. And if you live in Rhode Island, you have a cesspool. They're different depending on where you live in the state and sort of what the regulations are. You may be triggering or may be required to replace that at a property sale or within a year of the cesspool having trouble. So let's talk through the parts of a conventional septic system. These are really common sort of layouts. So a conventional septic system is usually made of 3 parts. So you have the house and the well over here in the cartoon, and all of the wastewater makes its way into the septic tank. That's the first compartment, which I'll talk about in a minute. Then water leaves the septic tank and makes its way to the distribution box. And then from the distribution box, it goes out to the drain fields. So we'll look at each of these in turn and kind of explain what they do. So the septic tank's primary job is to provide what we call primary treatment in the industry. And in other words, that means it's retaining solids. It's keeping solids in the tank and letting water leave. So water enters from the building. It comes in here, sort of the heavy bits that are denser than water sink to the bottom. So it's going to be like your toilet paper, your food scraps, your poop, things like that. And then things that are lighter than water, like grease or fats or oils or like the conditioner that you put in your hair, they rise to the top to form this scum layer. And so over time, sort of these things settle out and separate by gravity, and sort of fairly clarified water moves on over and then out to the drain field. You'll notice this is a modern septic tank as they use in Rhode Island. It has access risers, which are these manholes at the top, and it has a baffle, a concrete sort of wall with a gap in the middle of it to kind of create sort of 2 separate compartments that are connected. You'll also notice over here, there is a T that's usually made out of PVC, and that's the water leaves through, and there's something called an effluent screen, which I'll talk about in a minute. One thing to notice, though, even though there is air space at the top of this tank, there is actually no oxygen present. So that's important to know, because there can be septic gases which are toxic and corrosive. So you never want to stick your head inside a septic system manhole, in case you were ever curious. Any kind of available oxygen that gets in here instantly is used up by the microbes that are living in this area, breaking down whatever solids they can slowly over time, anaerobically, without oxygen. So over time, right, if septic tanks are providing primary treatment, retaining solids, they require maintenance, and you need to remove those solids. There, you need to pump your tank, okay? So what happens is when, you said the system is brandy new or freshly clean, people start using it, generating wastewater in the house. Water comes in and, the solids start to settle out and the water is moving on out to the drain field. There's plenty of room, everything is happy. Over time, the solids layer at the sludge at the bottom grows, and the scum layer at the top grows, and you end up having sort of less available space for that wastewater to hang out. So it starts moving faster, and it has a harder time settling those components out, right? Eventually, your tank could be chock full of solids, and there will literally be nowhere for that water to go. And so this is what your septic tank is supposed to do. It's supposed to keep the solids in the tank so that they don't move on to the next component. So I mentioned earlier, so there's an effluent filter, which is sort of like a mesh sieve in its basic form. And again, it's meant to keep any kind of small floating particles in the tank, not leaving the tank. And that means sometimes they get clogged and they need to be cleaned and rinsed off periodically. And that's an important function. Some people get frustrated if their effluent screen gets clogged and they are tempted to take it out. But a clogged effluent screen is doing its job. It's keeping those solids in the tank and from causing trouble later on in the septic system, in the distribution box or the drain field. So that's really important, okay? So Septic tanks require periodic pumping, and you should have an effluent screen. You can have one retrofitted if you currently don't have one, but then you need to have a way to get at that effluent screen and be able to have a professional clean it off. So that's important. So having these manholes or risers, even with the ground surface, makes it easier for the professionals to get in there, pump your tank out, take a look, make sure everything is working properly. If you keep these buried, that can be really difficult because A, it's harder to find your system, and nobody wants to be chipping away frozen soil in January when your system has a trouble. So, if you can get used to seeing those lids in your grass, that's always a good thing, so that you know where your system is and so that the service providers can get in there and do their jobs. So wastewater leaves the septic tank and comes into what's called the distribution box. And the distribution box is dividing that flow from the septic tank. And it's supposed to divide the flow so that it's sending equal volumes to all parts of the drain field. Usually the drain field has a couple of different lines, and so you want to kind of split that evenly. So basically the way this is a picture of the distribution box we have down, like normally this would be underground, obviously. But so you can see it, we can run water through it. So the idea is that water is coming in from that septic tank. It builds up between this little barrier and then trickles over this little weir. And then from there, it's split evenly into all the pipes that are leaving this distribution box, or one pipe per sort of area of the drain field. You'll see what this looks like in a minute. And so this is what the distribution box is supposed to do. But sometimes you can have problems with your distribution box if solids make their way into here from the tank. They can clog things up and cause trouble. Or if the distribution box is not perfectly level, or the pipes coming out of that distribution box are not perfectly level and even, water is always going to look for the lowest place to leave. So if one of the lines leaving your distribution box is lower than the other one, that part of the drain field will get way more water than the other part. And so that is hard on that part of the drain field, and sometimes you have trouble with that. Luckily, it's actually pretty easy to retrofit out of level distribution boxes. There's little plastic things people can pop into these openings and kind of equalize things. But again, that's something someone would have to dig that up and get at it to be able to do that. In the drain field now, what we're doing is providing final treatment to that wastewater before it trickles down into the groundwater. So you may remember that in the olden days, septic systems were sometimes called individual sewage disposal systems, ISDS, and now we call them an on-site wastewater treatment system. And the treatment piece is really important. We don't want to think of wastewater disposal. We want to think about wastewater treatment. And the soil in the drain field is doing that last pass at treatment before the wastewater makes its way down to the groundwater. So this is called a leach field. I call it a drain field. People call it soil treatment areas. They call it soil absorption systems. This is an example of a system being installed, okay? And so again, the point of the drain field is to deliver wastewater from the septic tank to the distribution box and then spread it out over the surface of the drain field where the soil underneath takes care of some of the contaminants. And there's lots of different configurations possible. So sometimes you have drain fields made out of concrete things called chambers or galleys. This is an example of a pipe on stone because it's pipe encased in sort of this crushed stone, which looks like gravel. And then there's like new modern versions that are variations on this, but they all basically kind of function the same. Here's sort of some schematics of some of those things. So the example that I'm going to show you in a minute of how all this works is the pipe on stone. So you have a perforated PVC pipe and it just sits in this sort of trench of gravel. That's what this looks like here. So the excavator digs a little trench, puts in some crushed stone, lays the pipe, adds a little crushed stone, they add filter fabric, and then they put the soil back on top, and the end. You never see it again. Sometimes folks have something called shallow chambers or flow diffusers. These are sort of concrete structures. They're about 2 feet tall, 4 feet wide, and they're usually installed in series, and usually you have sort of one set of these flow diffusers. You can have galleys, which are sort of the deeper versions. So this is an example of the training center. You can see they're 4x4x4 pieces of concrete with holes in the sides and the bottom, and they're sort of encased again. They're surrounded by this crushed stone or gravel. And so you'll notice I have color-coded my little like zone. So this blue down here is the groundwater. You'll notice I like color-coded some of this. So one problem with the galleys is this is all of the drain field for, say, a 3-bedroom house. Usually it's 1 bedroom per galley. You'll notice that that's not a very large surface area, and so galleys almost function like cesspools. They're deep in the ground. There's usually not a lot of distance to the groundwater, and they don't provide particularly good treatment. If you look at these shallow chambers or this pipe on stone, you'll notice there's more distance between sort of the bottom of that infrastructure and the groundwater table. And that means there's better treatment and less sort of contamination of the groundwater. So that's just something to keep in mind. So the soil, right, in the drain fields, like, how is it making this magic happen? So now we're looking at sort of a cross section of one of these pipe on stone drain fields. For this example, we have 3 lines. These are the pipes. They're encased in that trench of crushed stone or gravel. And then we talk about the infiltrative surface. That's basically where sort of our man-made infrastructure ends and the native soil begins. And then somewhere below there, you'll have a seasonal high water table. I told you this pipe is perforated, it has holes, so water trickles out, moves into the crushed stone, and then moves down through the soil. So we talk about separation distance here in Rhode Island, and that's how far above the seasonal high water table that infrastructure is supposed to be. There are rules and regulations that specify what that distance needs to be if you're close to the coast versus further inland. But old systems had different rules, so depending on the vintage of your septic system, that may vary quite a bit. So when we're looking at, so how is this wastewater moving through soil? If we were to take a magnifying glass and look at sort of this native soil, soil is made up of soil particles that kind of form together to make little crumbs, and then there's pores or little holes around them. And the water moves through these pores, although it does also very slowly sometimes move through these soil particles through the crumbs. And so these pores basically act like a sieve. So any microbes or pathogens that are in the wastewater will get caught by the sieve. The animation messed up. It's supposed to get caught by the sieve. And so the pathogens, the bacteria, get stuck in the soil instead of moving through the wastewater, through the groundwater. So that's one thing that soil does for us. The surfaces of all these tiny little soil particles also provide habitat for microbes. And the microbes that are living there are going to go after any kind of nutrients that make their way through the soil. And that is how the soil is doing the treatment. It's doing some physical filtration, but also there's some microbial activity that helps break down certain contaminants as the wastewater kind of moves through the soil. And so the idea is that by the time the wastewater trickles down all the way down to the groundwater table, your water is fairly clean-ish, and it's diluted by the rest of the groundwater and therefore does not pose a risk or a hazard to the nearby people drinking that groundwater. Okay, so you hear horror stories of people's drain field or their septic systems failing. What does that mean? Okay, so basically, if the water can't move through the soil and you're adding more water as you run the water in the house, like it's got to go somewhere, right? But if it can't go down, it will back up. Okay, and so it'll back up into the drain field, and if then it doesn't manage to find an exit, it'll back up into this distribution box, which is called D box. It'll back up into the septic tank, and if like all of that is full of water and there's nowhere to go, that's when you can't flush your toilet and your sinks don't drain because the water has nowhere to go. Okay, so why does that happen? Sometimes plants that are very aggressive and water loving can actually find your drain field, and it's like a basic hydroponic glory for a plant to get down at that wastewater. So they'll kind of fill up and clog things. They can break things, they can pull things apart, right? You've seen tree roots break concrete sidewalks. The same thing happens with that little PVC pipe below ground. So that can happen sometimes, and I'll talk about that in a minute. But really, usually this is a function of the soil properties and the biomat that forms in the drain field. And that affects how water moves into the soil and moves through. Those soil pores I showed you, those spaces between the soil particles, are allowing the water to move through. So if the spaces are big, the water moves fast. If they're small, the texture, if the soil is really fine, or those pores get squished out because they got compacted or something heavy was on top or something else happened, or a bunch of sort of fine particulate matter washed through and then clogged them up, the soil pores are not available to accept wastewater, and then the water can't move through. So oftentimes it's the biomat also that can cause trouble. So what in the world is a biomat? Sometimes people talk about this. So I have a little diagram. So here's our, pipe on stone drain field, and it's more or less the same idea no matter what kind of drain field you have, right? You have water coming in from the septic tank to the distribution box. It kind of trickles and fills up. It trickles into this pipe. And so this pipe is perforated down the entire length of it. Guess what? As soon as water finds an exit, it's going to go out that hole. So typically, we only see water coming out of the first couple holes in that entire pipe. The water really never makes it to the back. So that means the water kind of piles up here in the bottom of this trench and then moves through the soil pretty quickly and makes its way down to the groundwater. Okay. Now that was like day one of the system, first flush of toilet, that was the first thing. So over time, right, wastewater is juicy. It's got all kinds of carbon and nitrogen and phosphorus and all kinds of food for microbes. And sort of there are still some suspended solids that are in that murky water. It's not drinking water by any means. So what's called the biomat, which is like a biofilm. So if you ever have that slimy, nasty growth on any sort of wet thing, like your water bottle, if you forgot it in your car for a week, it is basically, it's bacterial and microbial cells growing together, then they die and they kind of glue each other together. So it makes this gloppy, thick, jelly-like sort of mat. And it grows kind of where the wastewater comes out because that's where the food is. And what it does is it helps the wastewater kind of pond up, and then it kind of runs off the edge of the biomat to the next part of the trench. So some makes its way through the biomat, some makes it past the biomat, and it trickles down and goes down to the wastewater, the groundwater, but now you've spread the wastewater a little further. And so over time, as you add more and more wastewater, this biomat will eventually grow along the whole length of the trench and kind of up the sides in all directions. And then it behaves like a little pond, so the water is actually distributed over the entire length of that drain field trench. And then you get water moving through that biomat slowly, kind of everywhere. And then you have that wastewater touching all parts of the soil underneath. And that's when you get really good wastewater treatment, okay? And so this is the goal. Now, there is air sometimes in this area. Air makes its way in from the atmosphere. And then, it kind of gets depleted when it gets kind of a dose of wastewater. If everybody's up in the morning and showering and you push some water into the septic tank, that's going to displace some water out to your drain field. So you get these sort of glugs of water over time. But sort of in theory, there's kind of this sort of steady state where like the biomat grows up a little bit, then it gets starved for a little while, dies off, and then the neighbors cannibalize each other. And so you have this sort of like growth and breakdown. And so usually after about 6 months, that biomat is in a pretty steady state and sort of in a consistently used system. You have that biomat in all parts of the drain field. That's all wastewater, and it's kind of helping distribute that wastewater. So that's important. What can happen is if there's too much flow because your system is undersized, say, and or you have too much organic matter leaving the septic tank, making its way into the distribution box, and then making its way into the drain field, the biomat can grow too thick. There might not be enough oxygen to help it break down intermittently. It's just too awesome for those microbes to grow like crazy. And so then when you get a dose of wastewater, the water has nowhere to go. It takes too long to kind of move through all of that jelly goo. And so then because it has nowhere to go, it's going to back up and find the easiest exit, right, which will be up into the pipe. It'll kind of build up into the distribution box. Eventually it'll build up into this pipe and get back in the septic tank. And then if it doesn't have an easier exit, it can build up and end up coming out of the surface of your drain field. And this is a failed system. A failed system cannot accept wastewater. So what do you do in this scenario? It depends. Oftentimes, then this is when you end up getting a new system. Sometimes if you rest the drain fields and like don't use it for a while, that will allow enough air to get down here and it'll kind of break down. But then if you start using it the same exact way again, it's just a matter of time before it builds up again and it like gets all gloppy and water can't go anywhere. So this is usually what causes a failed drain field. The other thing that can fail a drain field is if enough gunk got in here and it clogged up the soil pores, or that soil got smushed somehow and the water can't move through it. And then again, you have to excavate and start fresh, okay? So some things that would make your drain field sort of more prone or more at sort of risk for failure kind of fall into two categories. And of course, depending on if you're a professional or a home user, you're going to point the finger at the other. But oftentimes, there's multiple moving parts here. So if we're going to look at from the design or installation side of whoever the professional was that like designed the system and then installed it. So it could be that the system was undersized, and if the drain field isn't big enough to accept that wastewater, it's not going to be able to move through fast enough, okay? So this could be a function of the soil conditions, so if it's really fine soil or something funky happening below ground. If the number of occupants changed, so you added a bedroom, more people live there, but you didn't make your system bigger, that will then mean that your system is not big enough to accommodate the extra flow from those extra people. Or your system could be old and like the regulations were different or non-existent at the time. And so like it may have worked at its prime, but now 30, 40 years later, it's not doing so hot. So that can happen. It also can be if the person who installs the system doesn't do a good job, they can cause some problems and actually, cause issues with the system performing over time. So if they're not careful while they're using their excavator and they compact and they're driving across the drain field and or smearing it or doing work in wet conditions, you can squish out all those soil pores, that pore space, that airspace doesn't exist, and now it's all just like a big old pancake that water can't move through. That can happen. The other thing that can happen is when they install the system, they may not take the time to compact the soil where it needs to be compacted underneath pipes, for example. And then as sort of water moves through and that soil sags a little bit, the pipes sag with it, and then it kind of makes like a belly and it makes the ends kind of go high like a big smile. And that will change the elevations because this is all gravity based and elevation based. It can bring the elevations out of whack. So that's where like a crooked D-box or those pipes being out of level, sometimes it's a settling problem. Those pipes can bow or they can break depending on how much they settle or what's happening over the surface of that. Or if they use low quality materials, right, they may not stand up to the test of time. So these can all contribute sort of to the drain field. So when I talk with professionals, we talk about these things and like make sure you do specific things to make sure that when the system goes in the ground, it's off, gets off on the best foot possible. In terms of the user error here, so problems that can come up and potentially cause failure over time are when you don't adequately maintain your system and the system is not providing good primary treatment in that septic tank. It's not keeping hold of those solids and they're making their way out to the drain field. That causes problems. That's bad for the biomat. If the water uses a lot of water, the house uses a lot of water or there's like a leak, what it can do is it can stir up the septic tank. And so there's not enough time for that stuff to settle out. And so then it gets carried over. If you have one of those incinerator, garbage disposal grindle things, that small ground up food is small enough that it doesn't always settle very well. So if you have one of those in a septic system, those are not happy to things together. So if you have a septic system, you should not be using a garbage disposal because you're adding solids and you're adding solids that can easily make their way out to the drain field, especially if you don't have an effluent filter. Also, the way the property is used, maybe it was designed to be a 3-bedroom and now there's renters there and they're having wild parties every weekend. And like, renters are not going to be as kind to a system as someone who lives there and is their permanent residence, right? So that can sometimes play a role. And maybe a home office or a business starts or someone decides to do a home daycare and they're just sending a lot of different or more water than maybe the system was designed for. That can happen. That can cause trouble. And or if any kind of heavy stuff ends up on the drain fields, you can actually squish things and crack things or compact things, and that will all affect how the wastewater moves or leaks in the system without being treated. Okay. So another sort of problem, so say the system works perfectly, it was designed well, it was installed well, people are using it appropriately. There's still some areas that kind of have a problem with conventional drain fields, and it's this. The microbes that are living in this drain field are doing their thing. They can break things down, but it depends. So we get into nitrogen, and this is sort of the Cameo advanced system sort of preview that we won't have time to get into. But basically, because your septic system does not have any oxygen in it, all of the wastewater leaving your septic tank is in the ammonium form, like ammonium, like the kind that plants like, right? And so what happens is the ammonium trickles out of these pipes, and then at the first place it sees oxygen is usually below that biomat, because right, it built up and ponded above the biomat, and then it kind of moved through. And then it finds these soil pores, which are partly air-filled, partly water-filled, and there you finally have conditions to get nitrification, and that ammonia will turn into nitrate, okay? Right, and when Miracle-Gro is like ammonium nitrate, right? Like plants love this stuff. But what the issue with nitrate is that there's like this teeny tiny little minus, it's negatively charged, and soil is negatively charged. So that nitrate has nowhere to stick and often bypasses and moves very quickly into groundwater. Conditions are also not right for the microbes to kind of scavenge that and do anything useful with it, like change it to a gas. And so what happens is that if you have a conventional system, it does a really good job of making nitrate, but it doesn't do a good job of getting rid of nitrate. And so if that nitrate makes its way down to the groundwater, it can make its way into your well, or if you're at the ocean, it can make its way out to sort of the coastal water bodies, the salt ponds, or the ocean itself, and it causes problems there. So the problem with conventional drain fields is that they do not remove very much nitrogen. And that doesn't always matter, but it does matter sometimes. A lot of nitrogen in the environment is a problem for sort of human health reasons and for environmental health. So if you get nitrate and nitrite in drinking water, right, if you have low chronic nitrate, even just small levels below the allowable level for it to be drinking water, that's been linked to cancer risks long term. And if it's a high level, it's more than 10 parts per million of nitrate in your drinking water, you should never use that to mix formula for infants because they get blue baby syndrome. The nitrate basically makes its way into your bloodstream, pops the oxygens on your red blood cells off, and so they're suffocating, and their systems are still young enough that they can't fix that. That's why it also causes cancer in us more adult folks. Like over time, it's a lot of stress on the body to kind of detoxify this. On the environmental side, ammonium, if it doesn't nitrify, it makes its way into a surface water body. It's toxic to wildlife, to aquatic life. It kills all the fish, right? People who have aquaria worry about their ammonia levels. And in general, if any kind of nitrogen makes its way into a marine ecosystem, it can cause eutrophication, and those are those algal blooms that can eventually kind of deplete the oxygen in the water as they degrade and cause fish kills and shellfish kills and things like that. So in some places, we care a lot about nitrated drinking water, and we care a lot about the nitrogen that makes its way out into the environment. And so in those cases, then we need to think about this nitrogen. So there are these things called advanced treatment systems that are designed to remove nitrogen. And those are often required in areas where we need to think carefully about public and environmental health. And so oftentimes we call these areas critical resource areas, and which is like subtext for them being nitrogen sensitive areas. And that includes things like public water supply wellheads, right? You don't want a bunch of people adding a bunch of nitrate to the water that like is feeding the city of Providence or something like that, right? If you live near a coastal water body, your nitrogen makes its way to the coast, it can cause problems there. And so these areas often require nitrogen reduction, or sometimes they're called IA, which stands for innovative alternative, or AE, alternative and experimental systems. And these are, well-established systems that have a special thing that can remove the nitrogen from the wastewater. They basically turn it into a gas, so it goes into the atmosphere, so that it's not going down into the water. And so that protects drinking water and surface waters. And it also protects coastal waters, because in the coast, the groundwater does eventually make its way to the ocean. So for both of those reasons, in certain areas, you may need to upgrade to an advanced system if your conventional system fails, or if you build a new house. So like, how does this magic happen? I'm going to give you the like 10,000 foot speed view. So basically the short version of how this works is that these advanced treatment systems have some sort of like extra whiz bang patented glorious thing that some engineers stayed up late thinking about. And it has an extra thing. So a normal system, like we've been talking about, a conventional system has a septic tank that does primary treatment. And then eventually, right, there's the distribution box, then it goes to the drain field and you get final treatment. These advanced systems have this like whiz bang intermediate thing that does magic. And the idea is that it's removing nitrogen, it's reducing the waste strength. And so therefore, like you've controlled what that wastewater is like before you send it out into the soil, where now you have no longer any control over it. Okay, so that's a short version. How these systems work and what you need to know about them is like a whole nother talk. So, stay tuned. Okay, so, just kind of switch gears. Talking fast, making sure I don't leave you, keep you for today or tonight. So sort of my job to like you as a homeowner, right, living in the world here, what can you do to help preserve our local ground and surface waters that we rely on to drink and, recreate and swim and fish and kayak in, okay? So one thing, right, and this is not going to be news to any of our fabulous master gardeners, is like, think about your landscaping. Is your landscaping environmentally friendly, right? Don't use a lot of fertilizer. Be strategic about when you fertilize. Don't let the rain wash all that nitrate down into your groundwater or off into the storm drain, right? If you can bag your grass clippings so that they kind of mulch back into the lawn and you're not removing those nutrients, you don't have to add them, right? So these are things you can do. If you're going to water, do it a small amount, right? An inch a week might be enough, or let your lawn go brown and save greenhouse gas emissions from your mower, unless you're electric one, I guess. But so those are ways to keep things in, right? Plant your native species that are adapted to this climate and are happy with the rainfall we do or don't get here, okay? And if you ever have any kind of bare soil, keep that soil in place, cover it, mulch it, use some kind of ground cover, plant it, keep that soil from being washed away and carrying whatever's attached to it, which often is nutrients, into the nearest water body. And then because, you know, septic system is my life, here are some things that you can do specifically for your septic system to keep the water safe in your area. So one thing everybody can do, whether or not you're on a septic system, is to do your part to help wastewater treatment. So people consistently abuse wastewater treatment system, whether that's an on-site septic system or a centralized sort of municipal, like, you know, sewer. How? They flush things that shouldn't be flushed. Okay? And technically, if you flush something and it fits down the pipe, it does go away. That is true. But, you know, so like anything small enough, matchbox cars, flashlights, chicken legs, chicken wings, you know, the list is endless. You know, things that are small enough are flushable. But the idea here is that if it's not disintegrating as it moves through the pipes in the collection system to make its way into the septic tank or your nearest pump station, it's going to build up and cause clogs. Okay, so you want things going down the drain that like disintegrate and like become mush so that they can settle out and break down and not cause problems. You don't want that super strong paper towel that can withstand being wet and 900 pennies, or like your tissue that is made to withstand mucus traveling at fast speeds without getting on your hands, right? Those are not good things to flush because they're made specifically not to disintegrate. Okay, so basically the simple rule is if it didn't leave your body and it's not toilet paper, don't flush it. Okay, so, you know, and we know, and I'm sure you've heard about the fatbergs that are like building up in New York City and other big municipal things. And that is a function of the grease and all of the non-flushables that cause problems. So these systems that don't disintegrate build up because at some point they won't fit through something, or they'll catch some corner and kind of build up. And so they clog pipes, and big wastewater treatment plants are sort of, you know, like a centralized city system. They will clog pumps and lift stations that are pushing that wastewater, you know, from one area to that big wastewater treatment plant. In septic tanks, they cause problems, especially if they make their way out to the distribution box and, or God forbid, the drain field. Forget about it, new system for sure. And so when these things get flushed, basically somebody has to unclog that thing to be able to let the wastewater go where it needs to. And like, that is disgusting. That is somebody's job to climb down into various sewer pipe works and your septic system and like remove the things that you should have put in the trash in the first place. Also, it's expensive. I would advocate for paying people to do something less disgusting with their time, because we could just all throw our things in the garbage where they belong. It's my soapbox. Or because if you don't unclog it, you're going to have a sewage backup, and that is gross, public health hazard, and also expensive then to remediate, right? So, you know, don't flush it. And so if you're wondering, but I buy these things that say they're flushable on the label, that's a marketing ploy. Don't flush things that are not toilet paper or things that left your body, okay? Again, if it fits, yeah, it'll probably go down your pipe if it's flushable, right? If it's small enough, but that doesn't mean it's not going to build up and cause trouble later on, all right? So the other things that you can do, aside from not flushing garbage, are these. So one thing, if you're a homeowner, you have a SIP system, find out where that system is. Where is it in your yard? You should know, okay? So how do you know if you don't know? Because not everybody does. You could try and find the plans for your system. So, and that is, you know, you could talk to your local wastewater management office or the Department of Health, or in Rhode Island is the Rhode Island Department of Environmental Management. There's like an online permit search tool that, you know, if you Google DEM permit, you know, onsite OWTS, onsite wastewater treatment system permit search tool, you may be able to find your system or request public access to this record. You could ask your maintenance professional, they'll probably know where it is. And so the reason you want to know where your system is that you want to keep anything heavy off it. That includes vehicles. Like a ride-on lawnmower is probably okay, but that's about the max. Okay, you don't want anything heavier than a ride-on lawnmower going across your drain field. You don't want to put sheds or pools, like above ground pools, on top of your drain field, because that's a lot of weight and you run the risk of squishing, cracking, causing problems with things. You also, because of those like root systems and this glorious hydroponic situation, potentially, is you want to keep shrubs and trees and anything with a big root system at least 10 feet away from that drain field itself. Because you don't want, especially any kind of water-loving plants, to find those roots, have their roots find that system and then, you know, clog that up and cause trouble. That happens too. Also, you'll notice I have vegetables on here. The reason you don't want to grow vegetables on top of your drain field is not necessarily that they'll cause problems with the performance of it, although if you have a big raised bed, that's weight, blah, blah, blah. But what you don't want is any kind of septic system backup to contaminate the things that you eat. So vegetables should also be kept off your drain field. Okay, that's like a public safety kind of human health reason. Other things that you can think about, so watch how you use water in your house. So don't overload the system. Don't send 300 gallons in the tank at one day and then nothing the next day, because that's going to push 300 gallons out to your drain field. Okay, so a thing people don't always think about is like, when are you doing laundry? If you have laundry day, how many loads of laundry are you running back to back to back? How much water is that being pushed out to your drain field on? So if you can space them over the course of the week, that'll be easier on your system. If you find any of your fixtures leaking, even if it seems like a small leak, if you quantified how many gallons that adds up to a day, like if it's your well water, it's free, so yeah, but adding a lot of water to the septic tank will stir it up and will keep it from doing that good settling, and you can stir it up and carry some of the like lighter particles out to the drain field, which then can cause problems in terms of the biomass or some of the soil pores that are out there. If you're hosting lots of people at your house for more than like a short amount of time, and like people are going to be using the bathroom like multiple times, think about that. Think about how much water that is. Think about how many solids are being added, and consider whether the long-term cost payoff trade-off might be better for renting a porta potty. And that's something everybody's got to think about, but that is something to think about in general. Okay. So other things that you want to make sure that absolutely never find their way into your septic system are things like paint. So if you paint the inside of your house, or you're like an acrylic painter extraordinaire, you don't want that latex paint or acrylic paint making its way into the septic tank or the septic system, because guess what? It coats your walls nicely in a uniform film. It'll do the same to the inside of your septic tank and like all of the soil pores in your drain field. So make sure if you do work or someone comes and does work, rinse those paintbrushes like on the ground outside somewhere. Don't send that rinse water through your septic system, okay? Make sure that you're not adding any kind of harsh chemicals like heavy duty acids, peroxide, any kind of stuff like that. If you use like a cup of bleach a week to like do laundry and disinfect your house, that's probably fine. We're talking about 1,000 gallons of septic tank. A cup of bleach is not going to make a hill of beans difference. But, if you're using a lot of heavy duty industrial strength disinfectants, like if you're running a home daycare or some sort of assisted living, or, if you're taking care of someone with special needs, that may be hard on the microbes in your system. So just something to think about. There are additives on the market that are supposed to like seed your septic system, or people are like, oh, once a year I put a dead chicken carcass in my septic tank and I've never had a problem. Or they'll be like, add this stuff and never pump your tank again. All of that is nonsense. You want to be pumping your tank because you're supposed to be keeping those solids in the tank, not stirring them up and sending them out to the drain fields. And like most of this other stuff is just a waste of money, and you're better off putting that into your septic pump out fund and saving those dollars and paying the professional to come every couple of years and pump your system out instead of flushing literally money down the toilet. If you have any kind of excess or expired medications, talk to your pharmacist, or police stations can take those. Don't flush them down your system. Again, you don't want to be drinking your neighbor's medication. The microbes don't want to be dealing with that. It's probably not a good plan. And then if you have any kind of water softening system, if you have hard water, make sure that when it goes through its rinse cycle to regenerate the like water softening magic, it's not sending it to the to the septic system, because it's really, really salty water, which is really heavy, and it can sink below that heavy sludge that's supposed to be accumulating at the bottom of the tank and stir everything up. So there's ways to like pipe that to like a dry trench. Since it's just clean drinking water, it's not a human health hazard. So, talk to your local ordinances and find out if you can kind of pipe that somewhere else. It'll help your system behave better. And almost here at the end, one more slide. So other things that you can do to make sure that your system is behaving is that make sure you have a qualified professional come and take a look and tell you what's going on with that system. An ongoing multi-year relationship is a good thing here. You want to let them know if your household changes, like your kids move back home with you, or, pandemic life, everybody lived at home. I will tell you, the septic system industry has been busier than you could even imagine, because so many people are have been using their system from staying at home, that like systems that were like kind of croaking along and doing okay have now failed. And so like the number of replacements is like out of control. So if something happens and your household changes the way you're using and generating water, let them know. Or if people move out, that might kind of expand, like make it longer till you need a service visit. So kind of keep them kind of up to date. Keep those lids that let you access the septic tank, those manholes or risers or access covers, keep them even with the ground surface, but make sure that like kids and animals can't get into them and fall in, okay? Especially if you have an effluent filter on that outlet, that part of your tank that the water goes to the distribution box. If you have an effluent filter, you need to have a cover to the ground surface, or 2 grade, they say, because someone needs to get in there and clean that effluent filter. If that cover is buried 3 feet below ground, not everybody will be motivated to dig that thing up and clean your septic, your filter, which means eventually it's going to clog, and then so you're going to think you have a failed system because your water's backed up, but it's actually just like the screen is clogged and the water can't get out to the drain field, okay? So that's important. You should have an effluent filter and you should have that cover to grade. And then make sure whoever it is visits regularly. Have them give you a report so that you know what they did, what they saw. Have them warn you if things are like, oh, you know, like at the mechanics, which like everybody takes their car for regular oil changes, right? Your home septic system is kind of like that. Now, sometimes they cost as much as a car, right? So like do the maintenance. And like, you know, the free 30-point inspection that they give you at the car place, like tells you like, oh, you should start thinking about replacing your brakes. It's good to know that kind of thing about your septic system too, okay? If you're wondering like how often or what is regularly, like what does that mean? So if you have an advanced system, which I like only touched on, you should have a service provider visit twice a year. That's the regulation in Rhode Island, okay? And like I would get a report if it were me. Make sure that they're visiting, find out what they did, make sure they didn't find any problems. If you have a conventional system like the ones I was talking about, you should probably have a visit every 2 or 3 years, but like for all of these things, your mileage may vary drastically. You might need someone every year, and you might need one every 5 years. Your local ordinance may require someone to come every 3 years no matter what. So find out what the rules are and then find someone that will help you figure out. So what the pump out frequency is a function of is like how fast are solids being added to the tank versus how long does it take them to break down. So if you don't add very many solids, you may be able to go for a long time without pumping your tank. If you're adding a lot of solids, you'll need to get it pumped more frequently. So that's kind of how that works. And so someone that comes to your house regularly can measure your tank and tell you, okay, you're getting this many inches per year. When we get this many inches, it's time to pump. So you have 2 more years. You know, you can kind of do that math. And like find someone that you like and that you trust, ask your neighbor, and then like stick with them. And if you have an advanced system, don't let that maintenance contract lapse. Okay, it's really important to keep up with that. I think I'm going to leave it at that and skip to the end. So if you have any questions, you know, Kate will take them all from the chat and the Q&A, I'm sure. But if you want to send me an email, you always can. So my email is up here. Be kind, maintain your septic system. Our program has a website, and so you can always go there. There's fact sheets, information. There's kind of like everything maybe you would wonder about. And also has contact information for us as well. So, you know, don't be strangers. Part of Cooperative Extension is my job to talk to folks, and I'm always happy to do that.
Oh, I was almost speechless and then realized I was on mute. That was amazing. I've never seen this cartoon from our friend Don Biscay, who did a bunch of cartoons for us back in the early 2000s for stormwater. This is hilarious. Very Rhode Island. That was fantastic. As someone who lives in a home with a septic system and owns a home with a cesspool, there was a lot, I know, there was a lot to take in there, and we have some really great questions, and I want to try to get to as many as we can. There's a couple in the chat that I will go to first. So folks, now is your chance. If you want to ask Dr. Cox something, she's here for us. I say us because I have one of each. So let's start. So our friend Lynn was asking if septic systems in Massachusetts and Rhode Island are similar. And I'd assume that is, you know, in terms of regulation, what's required, design. Could you talk a little bit about that?
They're basically similar. So in Rhode Island, septic systems like design permitting is all managed by the Department of Environmental Management. In Massachusetts, it's the DEP, and Title V is like the set of rules that govern septic systems. And some of them are slightly different. Like some of the rules for like how your septic tank is. I showed a septic tank with like a gap in the middle between that concrete sort of separator. In Massachusetts, you have like two pipes connecting, and it's like slightly different. That's a difference. And then sort of how the drain field is set up. Sometimes in Massachusetts, they have you put like a different kind of material to take out some of the native soil and have different material. But all the same principles for a conventional system are basically the same. It's the same idea. You're trying to get the wastewater treated before it makes its way down to the groundwater table. You want to keep that infrastructure up above the water table and try and give systems enough time. So that is sort of like the really overview question. When you start talking about advanced systems, that's when things change a little bit more, but still there's a lot of overlap of when these advanced systems are required and like what's required of them. And then it depends on what part of Massachusetts you live in, because the counties also then control, and the boards of health are the ones that sometimes set that policy and have more stringent requirements than at the state level.
So in Rhode Island, DEM, you can go to for regulations, or they can contact you. That's great. So we have
some towns also here have like regional wastewater management offices, so you could also talk to them, like Charlestown and Tiverton and Portsmouth, North Kingstown, Westerly, South Kingstown. You may be able to talk to someone at the town too, and sometimes they also have ordinances that are more stringent than the state level. So I would start with like whoever your town people are and then move up the chain.
Sounds like coastal communities have stricter regs. So if you live in a coastal community, your best bet probably is to go right to your town hall first and then go up the chain from there. So lots of questions here. There's a couple questions from folks wondering how long a typical septic system or conventional septic system lasts if it is maintained well. That's the $1 million question, I think, but
It's like one of those things, like now I'm being recorded, so what do I want to say, right? So like, so the lifespan of concrete, say, right, is like 30, 40 years. So it depends on the materials. It depends how that system was put in, and it depends on the level of abuse that system has gotten over time. And so, if it hasn't gotten any abuse, then it's going to be a function of when those materials start to break down and crumble. So, a 30-year-old septic tank, it's probably looking a little long in the tooth there, So what happens is that all of those gases in the headspace of that tank, you have hydrogen sulfide forming, and it corrodes the concrete, and it like kind of starts to crumble inside. You can have a tank get cracked, and then now storm water is getting in, which is going to store things up, and wastewater is leaving and just like trickling down the side of that tank, and like not really good for treatment. And so the older your tank is, the more, so that's the thing. Also, if you have a tank that like predates the 1980s, or you have a system that's still from the 60s, it could be a steel tank, and that actually, it may no longer be structurally sound. So you may be, like, it could collapse at some point. And so that's also oftentimes one of the things that you worry about for cesspools, is that if you ever notice any kind of like sinkhole looking action, stuff starts to dip down. Nobody really wants to replace their septic system, but that is like danger. I would like rope that off with some snow fencing and call someone as soon as I could, because like someone could fall in and like drown in your human sewage. Not really something you want to have on your conscience, right?
No.
So, that's things to pay attention. So if you have a cesspool, it should be pumped and it should be inspected every year. And once sort of any kind of failure happens, then it's time to replace it. So that's important to know.
Great, writing that down. Okay, more questions. So for wastewater purposes, is an in-sink garbage disposal ever a good idea?
Only if it's a brand new house and you tell them that you're going to have it and they make your tank bigger. So usually the rule of thumb is that if it's a brand new house and like the person can't live without their incinerator, which is like, that's fine, it's your prerogative as a homeowner, they will like up the size of that tank. So if a 3-bedroom requires 1,000-gallon tank, say, they would say, okay, we're going to put in a 1,500-gallon tank, because you want to have that extra space. So The only time it would be cool to retrofit your system with an incinerator is like never, basically. So if you have one, it may be worth examining that and taking it out, which is not something everybody wants to hear. But in terms of wastewater treatment and protecting your investment, taking that little sink basket and dumping it in the garbage is probably cheaper and less annoying than having your whole backyard dug up for however many thousands of dollars it will cost you to do that.
That explains why you don't see them in new construction often. It's kind of like it was kind of an a la carte option that doesn't really serve great purpose, I guess. There's another question about grease disposal, assuming that bacon grease or other types of grease should be collected in cans and not dumped down the drain. This is an ongoing argument in my house. Glad this is being recorded.
Correct. Yes, I talked about it sort of in passing, but you're right. So, if you send grease that is solid at room temperature in particular down your drains, you never know when the temperature is going to be low enough for that to like solidify and congeal, right? And then like make it impermeable to water. So you can have a clog issue. But also, even if it does make its way into that septic tank, that grease and those oils and those fats really don't break down very well in that tank. And so you're just going to have to get your tank pumped more frequently. So from like a protecting your pipes perspective and from like not needing your tank to be pumped all the time, yes, as much as you can, if you can keep oils and greases and fats and any of that like gooky stuff in a garbage in a can, solidifying and then put in the garbage, that's the best place for it. Again, grease did not leave your body and it's not toilet paper. So it automatically falls into the category of like, don't flush or rinse it.
I'm gonna come up with a tagline for that somehow.
I guess like soap. I guess I gotta add soap to that, but like, then it starts getting complicated. That's like 3 things. But anyway, good question.
Buddy is very excited about this new information. If it didn't come out of your body, or if it's toilet paper or soap, it shouldn't go down the drain. So Jen in Joshua Tree is asking how often the septic system should be pumped, with the caveat that she does not have a garbage disposal. Everything that goes into the system is body waste and some toilet paper. Is there a general rule of thumb there?
So it varies, and again, this is like it varies because everybody uses their system differently. And so so people come and pump your tank, but what they can also do is they can take, basically it's like a big clear straw, and they stick it in your tank and like close it off and they lift it out. It's called the sludge judge, is like one of the brand names. And so what you can look at then is a profile of the tank, and you can see, how many solids or how much like scummy stuff is at the top, how much of it is clear, how many solids are at the bottom. And then usually you want to pump the tank when it's somewhere between 30 and 50% full of solids, depending on if you're like a high risk system that gets a lot of use, then you want to do it at 30%. If it's just like, 2 adults living there, low impact, 30%, 50% is probably fine. And so you want to kind of establish what your rate of solid accumulation is. So how many inches per year are those solids going up? Because you want to pump it at or before it reaches that 30% or 50% mark. And so that's why you want to have the same person come over time, because in theory, before they pump your tank, they'll stick that tube in and look at how much is in there, and then they can calculate how much time went by since the last time. Okay, how many inches do we have now? And then they can kind of extrapolate and predict, okay, you're good for another 2 years. And that's called an inspection years, when they just come without pumping it, and that's a lot cheaper than actually having to pump, remove that sewage, and then they have to pay to get rid of it at the centralized treatment system. So it varies, usually somewhere between 2 and 5 years. But some homes need it every year, and some homes can go 7 or 8 years. And it's super variable. And that's where like having the same service provider for a long time and having sort of that history would be really helpful for figuring that out.
Yeah, this is really helpful. If someone has 2 green lids, does that mean they have an effluent filter?
Probably, unless someone took it out and didn't replace it. Most likely, yeah. So an easy retrofit are those green circular lids. And so, yeah, you could ask your service providers like, hey, or you can, be careful. You can usually tell if you Google septic system effluent filter, you'll see some pictures of it and you could always like open it and look, but like obviously be very careful around an open septic tank. Disclaimer. So not for the faint of heart. So you could just call your professional and ask. They'll probably know.
Yeah, keep your pets inside during that.
And children.
This is a good question. Can a system be replaced in the same area, specifically the leach fields? Do you need to find an alternative area, and if so, why?
Depends. It depends on the reason why the system failed. And so if they can figure out why it failed and it wasn't a function of the soil pores being clogged or smushed or something, it may be possible to put the leach field in the same place again. And also side note, like if you replace your leach field and your tank is more than 10 years old, you should also just go ahead and replace your tank so that you don't end up with like a broken tank that compromises your brand new leach field. Side note. But so it depends. And so that is going to basically come down to like what the professionals think and what the regulators think. So sometimes you can put it in the same place, but if it's a function of how big or small that drain field was and it wasn't sized appropriately for the soil conditions there, you may not be able to put it there. If like the damage is done, that might be it. Yeah, it depends. So oftentimes it's easier to just like abandon a below ground misbehaving drain field and just like set up shop in a new area of your yard. But if it's like a repair situation, that's not always possible. So, you know, usually the rules for repairing an existing system, like, you know, you lived there for 20 years, your system fails, what do? You know, they're a little bit more flexible and you can do some things on repairs that you couldn't do on new construction because like basically you got to make the best of everything, right? And like the regulators understand that. So it depends. And not everybody goes to the trouble of troubleshooting and figuring out why a system failed. Not all of the professionals do that. And so if you don't know why it failed, then it makes sense to move it. If you want to invest the time and sort of like sleuthing and find someone that can do that, it might be easier to determine what the, you know, whether or not. So depends.
Yeah, it's interesting. And just thinking about this in the landscape worlds, a lot of these questions, when we say it really depends, it really is a matter of the site characteristics, you know, the soils and the slope and the whatever the feature is that you're looking at. And it strikes me that it's very much the same situation with septic systems. And frankly, like we tell people for landscape management, if a lot of this stuff is, you know, stuff you don't necessarily want to try to figure out on your own, having a professional you can trust seems like a really good relationship to build. And so that brings me to a question I have, which is around the folks who come to your training programs. Alissa, is there a list of professionals people can look at who have been through your, you know, our URI, I should say our URI training program? Are there, you know, can we guide people towards the folks who have done the work, so to speak? Because I just wrap up by saying it strikes me that, you know, the more informed we are as homeowners, the better off we are. I've learned a ton sitting here. But I think also not putting the pressure on ourselves to handle some of this stuff and giving someone some business and helping them make a living is also a good thing. But we want to have a good person who's knowledgeable doing it.
Yeah, so a couple of answers to that in lots of different ways. So we have a list of folks that have been through our inspection class. So if you want someone to inspect your system and give, like, we have a list of all the people that have taken the class and passed the exam. I would argue that you would want to maybe start with that and then start asking friends and family, like, do you have a service provider that you like and that you would recommend that you feel like doesn't like do shady things or charge you weird fees for no apparent reason or recommend extra things that like didn't seem like they were necessary, right? That's like many like sort of home improvement professionals, like word of mouth may be also almost more valuable. Some of our classes, you know, so we have a list specifically for inspections, but in terms of designers and installers, we don't have any kind of special list for people that have taken certain classes. But you could always ask, if you're considering hiring someone, I would have a conversation, like what's important to you, and like they should, you know, within reason, entertain some back and forth, be willing to explain what and why and how and understandable. They should be able to say like, well, we could do this, but I think this is a better thing because. They should be willing, and you as an informed consumer, it helps you to do some of this homework and know some things and ask questions and like get a feel for whether this person is a creep or seems like a legitimate person, right? That, I mean, it's the same kind of no matter what. So there, that's that. The other thing I wanted to say when you were talking about sort of the site constraints, that is all true. And you also have to think about your well and your neighbor's well, and can your system be far enough from both of those to not make it so you're drinking, somebody's drinking somebody else's poop. So that then also gets complicated. Sometimes the only place you can locate a drain field to be able to be at least 100 feet from any well also constrains. Not only are there soil conditions and slope and, you know, existing trees and whatever else is on the property, giant boulders left by glaciers, you know, pick your poison. It might also be a function of like, where are the nearest wells and how can you get as far away as possible from them?
Oh, fascinating. There are a few other questions. Let's let's close out with some Ridex questions. So there's a couple of folks who are asking about using Ridex to preserve a septic system's function, and also you know, should that be used on in vacation home settings where the system isn't being used more than 5 weeks a year? Can you just talk a little bit about that product? And
So in general, there have been research studies that looked at, and basically there's no, and since like as cooperative extension people, we care about the science, there is no documented scientific evidence that any kind of septic system additive to seed your system with beneficial microbes or what preserve your system. Mostly creative marketing. And so again, there is no, so there are microbes being washed off your skin every time you take a shower or your clothes go through the washer, right? Because like your clothes have snuggled with your skin. And so they, you know, every time you use the bathroom, there are microbes making their way through. There's plenty of microbes living in soil and they like, you know, wash through from the rain and the ground surface. Like there's no reason to have to like worry about the microbial community in your septic system needing any kind of help if you're not putting any kind of microbial inhibiting things into your system, like heavy metals or harsh chemicals or crazy amounts of heavy duty disinfectants, right? Like those things that kill microbes in large quantities could cause trouble for your septic system because like microbes are making a lot of the magic happen there, as some of my colleagues like to say. But so, you know, there's like various products that people always ask about, and like, you know, people talk about like seeding things. So there is no scientific evidence that that's a good investment or that it does anything. It might make you feel good, but again, I would say put that money into the like septic tank pump out, maybe give it as a tip to your service provider if you did your good job. You know, that's probably going to be a better use for that money. In terms of seasonal homes and those systems, so this talks a little bit about some of the research that one of my colleagues did when she looked at some of the advanced systems. And so the good news is that most of the advanced systems are fine. They work just like the way they're supposed to, even if they're only used intermittently. So that's good because like it's the same amount of money whether you use it all year or not. So that's reassuring. In terms of like if it's a conventional system, right? If your system is not used for long periods of time, probably that drain field biomat is going to break down and you're going to have to kind of start from scratch when it starts being used again. So your wastewater treatment may be somewhat compromised in that you're not using that entire drain field. So now the water is moving through a smaller area of soil and it's going to be wetter and move faster than if it were spread out nicely. So that's just a thing to think about, especially if your well is near your septic system, which again is why you should know where these things are. You know, so that's something to think about. Hopefully that answers that question.
well, I think this answer this session answers the question in my mind about if we need to continue um, having these learn at home webinars on these somewhat complex topics that homeowners are thinking about, on-site wastewater treatment, wells, landscape care, lawns. I mean, all of this is really practical, useful for those of us who own property and ultimately are responsible for all of this functioning. And I think one thing, not that Alissa has not inspired you all to really take a harder look at the function of your own septic system or cesspool, but one thing I just wanted to close with is that um, from my perspective in the course of time I've been doing this work, I hear from regulators and policymakers and water quality specialists, and that when we look at why we have water quality degradation in Rhode Island specifically now, time and time again, tests and tests after that, failing septic systems and cesspools are consistently in the top three in terms of what is causing water quality degradation. So in Rhode Island, and so when we have shellfish area closures or beach closures, it is the functionality, for better or for worse, of these systems that are impacting our areas we recreate and rely on for habitat. And so never mind drinking water. And so it's really, really important that we do our part individually. I've been having a crisis of faith in my own life with the fact that I do own a home with a cesspool. And so, the minute that property changes hands, which will be soon, that will be replaced probably with a top of the line septic, because I know that's the right thing to do. So lots of thank yous in the chat about how informative and easy and clear this was to understand. So kudos to my friend and colleague, Dr. Cox. Folks, we have one more webinar in the Learn at Home series scheduled for July, 2 weeks from today, which I believe is July 13th. Hopefully I'm not getting that date wrong. If you're not able to join us, then it'll be on YouTube by the third week of the month, as will the recording of this session. So check back on the URI Cooperative Extension YouTube channel. If you don't follow us on social media yet, you should now. And until next time, thank you so much for being here. Thank you, Alissa. I could listen to you all day. Folks, thanks for supporting our work, and we'll see you next time. Good night.